Okay, today we're going to look at the beginning of chapter 4 called inverse functions. So we need some definitions here. Our first definition is definition of a one-on-one function. A function f is a one-to-one function if for a and b in the domain of f, if a equals b, then f of a equals f of b, or equivalently, if f of a equals f of b, then a equals b. Okay, one thing we can do to test for a one-on-one function is called the horizontal line test. So we can test for a function using a vertical line test. We find it's a function. We can test for a one-to-one function by doing a horizontal line test, which is basically the same in that a function defined by y equals f of x is one-to-one function if no horizontal line intercepts the graph at more than one point. So something like this would not be one-to-one. Something like this, however, would be. So, what is an inverse function? That's what the chapter is titled. If we let f be a one-to-one function, then g is the inverse of f if the following conditions are both true. The composite of f and g of x equals x for all x in the domain of g, and the composite of g and f of x is equal to x for all x in the domain of f. So let's see if we have something here we can look at. Determine whether the function is one-to-one. So we'll look at f of x equals negative 4x plus 1. I think I got ahead of myself here. Yes, it's already given us inverses when we haven't looked at it. Okay, so we're going to test to see if these two functions are inverses of each other. F of x equals x plus 6 over 2, and g of x equals 2 times x minus 6. So let's see if they are inverses. So f, cos of the f and g of x means place g in for x for every x. So we have equals 2 x minus 6 plus 6 over 2. Well, the 2's cancel out, and I get, actually the 2's don't cancel out because this 2 cancels out, but this becomes 3, and that's not the same. So those are not. Let's look at another set. How about f of x equals 5 over x minus 2, and g of x equals 2x plus 5 over x. So we'll start with composite of f and g of x. So I have 5 over 2x plus 5 over x minus 2. First thing I can do is multiply this negative 2 by x over x. I have 2x plus 5 over x minus 2 times x over x. 2 over x, 2 over x. So now I have 5 over 5 over x. Remember this, just bring it up. 5x over 5, which is x. So far, so good. Then we test this composite of g and f of x. So now I plug f into g. So I have 2 times 5 over x minus 2 plus 5 over x. So we have 10 over x minus 2. Go ahead and multiply 5 by x minus 2. Plus 5 times x minus 2, which is 5x minus 10 over x minus 2. And this is all over x. So now the 10's canceled out. And I have 5x over x minus 2. Over x. And this is not working. Let's look at this again. Okay. So I'm looking at G composite F of x. So my G of x is 2x times 5 over x minus 2 plus 5. Okay? And that's just over x. So here I have 10. That's where my mistake was. X minus 2 plus 5 times x minus 2 over x minus 2. And this is all over x. So what do I have here? I have 10 plus 5x minus 10 over x minus 2 all over x. Did I write something down wrong? Five over x minus 2, 2x plus 5 over x. Yeah, that's where I messed up. Got to be very careful with these. Don't think we'll be testing beyond this. I forgot to replace x with 5 over x minus 2. There we go. So now I have 10 over x minus 2 plus 5x minus 10 over x minus 2 over 5 over x minus 2. Since everything's over x minus 2, I can just get rid of that. 10 minus 10, so I have 5x over 5, which equals x. There we go. So now we proved it. That brings us to the last thing in this section. How to find an equation of the inverse of a function. For a one-to-one function defined by y equals f of x, the equation of the inverse can be found as follows. Replace f of x with y, interchange x and y, solve for y, and then replace y with f inverse of x. F inverse of x. That is not f to the negative first power. It is f inverse of x. So let's look at f of x equals 4x plus 3. Well, this is a line, so we know it's going to be 1 to 1. Okay, so first step, replace f of x with y. Second step, interchange x and y. X equals 4y plus 3. Then solve for y, so x minus 3 equals 4y. X minus 3 divided by 4 equals y. Then, don't forget, f inverse of x equals x minus 3 over 4. Okay. Let's look at another one. Let's look at n of x equals x squared plus 1. Now, there's a problem with this. This function is not 1 to 1. However, if I say for x less than or equal to 0, then I'm only dealing with this half of my parabola, and I'm okay. Now it's 1 to 1, so now let's find our inverse. Change n of x to y. Exchange x and y. Solve for y. X minus 1 equals y squared. Y equals square root of x minus 1. And since here x has to be, here y has to be less than or equal to 0. So we only want the negative square root of x minus y. So that's how inverses work. And that's the end of section 4.1.